This is Project 22076 with Kate Willa Brown-Requist, Tristan Erb, Skylar Mangiafico, Victor Nieto, Tennyson Wilson, and William Martinez. The Gay-Lussac Arvidsson Mine Company borate deposit in Chavez County, New Mexico shows favorable geological and economic conditions. The deposit is high-grade, located below a layer of overburden, resulting in high stripping ratios in the early years, but very favorable stripping ratios when open-pit mining in the later part of mine life. Technical difficulties with the geology team's sub-block geologic model and lack of time to receive a new proper block model deemed it impossible for our team to use economic evaluation and design softwares initially. The second design phase included proposed designs for drilling and blasting programs, as well as an assay and sample prep program.
Hey everybody, so now we're going to be talking about the competition description. The, the SME Student Design Metallic Competition included two phases. The first phase was a pre-feasibility report for a mine. This was 40% of the final score. This detailed report included things such as the mine life, the mine plan, where the mine was located, and how things such as tailings and other things were going to be designed. For the report, we had 21 days, with each member of the team having a limited working time of 25 hours per member. We then submitted the report and got the results back. If you were the top 6 teams, you made it to Phase 2, which we did. Phase 2, there's a major change in the original project description, such as the mine is now a gold mine and not a copper mine. And so you have to make a huge change to your feasibility report. And the main goal of this is to make a presentation on the change and how we adapted to that. We present this presentation at the SME convention in Salt Lake, and it's 60% of the final score. In total, for both phases, we got second place in the entire world.
Methods, we utilized a variety of software to calculate site layout, processing costs, infrastructure, and reclamation. Our first program was MetSim, which was used to build our processing design, create a process flow diagram, and understand the mass balance to separate our 3 main products, 5-mole boric acid and lithium carbonate. It also allowed us to utilize equipment layout and specialty to understand our recovery rates on a yearly basis. Our second program that we used was Hexagon Mine Plan 3D, which allowed us to create an open pit layout, understand the infrastructure layout for our processes and our reclamation, as well for our waste and tailings. Utilizing the block model, we were able to design an optimal pit design layout for the entire mine life on a quarterly basis and oversaw increased revenue as the mine life continued, as well as increased operating and capital costs as the mine started to close down. Our last program that we used was CostMine and Sherpa. This allowed us to pull from databases from previous mine infrastructure layouts, as well as processing design, and to understand labor cost. These programs allowed us to understand and calculate on a capital cost, an operating cost, and a labor cost, and how much labor we would need for the entire mine layout.
So here we have our proposed mine layout, including waste dumps, tailings impoundments, processing facilities, water treatment plants, and lithium ponds. We also have a thorough mine design where we have used the ore body information to design the most optimum mine possible in order to maximize profit as well as minimize environmental impact. So here we have our intended blast pattern design. We will be using a staggered blast pattern, which will produce a 50-foot bench height, and we'll be blasting approximately 500,000 tons, and it will cost around $130,000 per blast. After blasting, our material will be trucked to the processing facility, where the ore will be loaded into direct drive crushing, transported via conveyor to the cone crusher in hydroset, and then moved to the ball mill to finish the crushing process. And then the material will go to the water hydraulic cyclone, and from there we'll go on to the next processing facilities to separate lithium from boron. So throughout our entire mine project, from blasting all the way through our processing, we will be taking samples to ensure quality control and to best understand our material in order to optimize our extraction. And here below you can see our facilities for our assay as well as our sample prep. So here we have our discounted mine cash flow as well as our operating costs over the course of the entire mine life. We will have an estimated $2.9 billion NPV value over the entire course of the 11.25-year mine life. We will have approximately $14.7 million in capital cost, as well as a $33 million annual operating cost, including personnel and equipment.
So to summarize, the final mine plan has a net present value of $2.92 billion with an 11.25-year mine life. The ore production remains constant throughout the mine life at 5.2 million tons per year. And then this team finished second place overall in the metallic mine design competition for 2022. So to summarize our supporting material, CostMine's cost estimation sheets were used for operational and capital expenditure costs. CostMine's Sherpa was used for mineral processing costs. Hexagon's mine plan was used for the mine layout. MetSim's process modeling software was used for the milling and processing of the ore material. And then finally, Microsoft Excel was used to compile and visualize all of the data.